Let's talk about how to subset an array in R. We can subset an array in R in much the same way that we can subset a matrix. More specifically, we can use the square bracket operator and provide vectors indicating the desired positions in each dimension that we want to extract, with each dimension being separated by a comma. So if A is an array with 3 dimensions and we want to select a rectangular subset of A, then we can use the syntax A, and then in square brackets we have v1, v2, v3, where v1, v2, and v3 are numeric vectors indicating the desired elements in each dimension that we want to select. So let's look at some examples because there's actually a lot that we can do with this. So we're going to create a 3-dimensional array that has the values 1 through 24. The first dimension has length 3, the second dimension has length 2, and the third dimension has length 4. And as a side note, the reason I'm using print A here instead of just having A and using that to automatically print to the screen is because in Jupyter Notebooks, for some reason, it doesn't render properly otherwise. So I have to manually specify print A here to get the right format. And so we can see here that we have our array A with 3 different dimensions. The first element of the third dimension is this 3 by 2 matrix here. We have something similar in the second element of the third dimension, and so on. So let's say that we want to subset the first element of the first dimension of A. If we only specify the first element of the first dimension of A, then everything in the second dimension and the third dimension is going to be included in our subset. So this is going to run across the 2 elements of the second dimension of A and across the 4 elements of the third dimension of A. So I'm going to use my square brackets here. I have 1, comma. Because I don't specify anything after these commas, that means we want everything in the second dimension and everything in the third dimension. And when I print that, I get 1, 4, 7, 10, 13, 16, and 19, 22. So what exactly is going on here? Well, I said I wanted everything in the first element of the first dimension. So I select these 2 elements in the first row of the matrix that's stored in the first element of the third dimension of A. And so I get 1, 4 here, which is what I get right here. I get 7, 10 from the second element of the third dimension of A, which is right here. 13, 16, which is right here. And then 19, 22, which is right here. So you have to think a little carefully when you're thinking about how you're extracting subsets of multidimensional arrays. Let's subset the second element of the second dimension of A. This is going to run across all 3 elements of the first dimension of A and across all 4 elements of the third dimension of A. And so similar to before, I have A, I have my square brackets. Before the comma here, I have an empty space indicating that I want everything in the first dimension of A. Then I have 2 in the second dimension here before the second comma. So I want the second element in the second dimension of A. And then because I don't have anything after that comma, I want everything in the third dimension of A. So when I run that, I get a slightly different result here. So if we go back up here, if I want everything in the second element of the second dimension of A, I'm going to want 4, 5, 6, 10, 11, 12, 12, 17, 18, and 22, 23, and 24, which is what I have right here. We can select more than one element, of course, by supplying a longer vector in the appropriate position of the square brackets. So we're going to subset the second and third elements of the third dimension of A. So basically what we want here is the second and third slices, of the third dimension of A. So this is going to run across all 3 elements of the first dimension of A and across both elements of the second dimension. So we have A, we have our square brackets, we want everything in the first dimension and the second dimension, so we leave those blank. And then in the third dimension, we specify 2, 3, so we only want the second and third elements of the third dimension of A. And when I print that out, I get these 2 smaller 3 by 2 matrices in an array of length 3 by 2 by 2. So I'm only selecting these 2 elements right here of my larger array A. So I want to talk about a special case. So if we subset an array such that the subset can be thought of as a vector. So say, for example, we did a subset here and we get a 1 by 1 by 4 array. That's essentially equivalent to a vector of length 4. Then by default, R is going to automatically convert the subsetted object to a vector. And the reason is because the square bracket operator has this hidden drop argument. So it's always available to use, but its default is just normally set to true. We don't even worry about it. Doesn't usually make that big of a difference. But because the hidden drop argument is set to true, by default, when we try to subset something that can be converted to a vector easily, then R is going to, by default, coerce the result into the lowest possible dimension. So in this example here, I'm going to select the part of the array A where I have the first element of the first dimension, the first element of the second dimension, and then everything in the third dimension. So that's actually going to be a 1 by 1 by 4 array. And so if I print that result, I get an array. So this is just a standard array, so 1, 7, 13, and 9. If we wanted to make sure that we returned an actual array and not just a vector, then we need to specify the drop argument and set it equal to false. So if we set drop equal to false and run the same command as before, we can see now that our result is returned in an array format. So let's look at a different context. Let's say that we want to select specific elements of an array and not a rectangular subset. So there are specific elements in our array that we want to select, and it's not just like a section of an array that we want to select. If we want to do that, then we can actually pass a matrix that indicates the elements we want to select using the square bracket operator. So the number of columns of the matrix that we're going to pass into the square bracket operator needs to match the number of dimensions of the array we're subsetting. So if we have a 3-dimensional array, our matrix needs to have 3 columns. If we had a 2-dimensional array, then the matrix would have 2 columns. A 4-dimensional array would require a matrix that had 4 columns, and so on. And then each row of the matrix that we pass to the square bracket operator is going to indicate an element that we want to select. So we're going to do this for our array A that we've previously defined. What we're going to do here is create a matrix V to subset the elements in positions 1, 1, 1, and 3, 2, 4 of our array A. So I'm going to use the cbind function to create a matrix that has this as the first row and this as the second row. So I've kind of done this in kind of a clunky way here, but I took the elements 1, 3, the first positions of these vectors here, 1, 2, which is the second positions of these vectors, and then 1, 4, the last positions of these vectors. I cbind them together to get V, and you can see that we have 3 columns because A has 3 dimensions, and the first row is 1, 1, 1, and the second row is 3, 2, 4. In order to use that matrix to subset the appropriate elements of A, we pass that matrix to A inside our square brackets, and I print the results. And I get exactly 2 elements, which makes sense because we're selecting the element in position 1, 1, 1, and then also the element in position 3, 2, 4. And if we compare that to our matrix A above, we see that the element in position 1, 1, 1, 1, 1, 1 is the value 1, and the value in position 3, 2, 4 is 24. And when we go back to see what was printed, we see that it was 1 and 24, which is exactly what we expected. Lastly, I just want to mention that we can also use the minus or negative syntax we learned with matrix objects to subset parts of an array that are not in certain positions. So we can exclude certain elements of the first dimension or the second dimension or the last dimension and so on. I'm not going to demonstrate its usage here. That's not my favorite way of subsetting matrices or arrays, but that syntax is also available if you want to use it in your situation.